show you how to manipulate an NMR spectrum using the Delta software. This is something that you would want to do if you needed to, for instance, change the integration, find a better way to display some of the signals, and perhaps to annotate the spectrum. So this is a spectrum from a recent experiment, and you can see that the integration doesn't look right because there's no way that one could have 55.8 protons. So the first thing that I tend to do is I like to zoom in just on the region of the spectrum where there's actually signals. And so here it is. And right away I know that this signal at 7.248 ppm, that's the signal for CHCl3. So you shouldn't be integrating on that. So the way to change that is you go up to this menu line here. These are all the keys that you're going to be using for manipulating spectra. Don't use the keys up here. So the first thing, if you're going to be playing around with integrals, is to click on the integral icon. And if you click on the red line, just a left mouse button click, you'll see that it changes to this blue color. And all you do is you just hit delete on the keyboard and that integral is gone. Now the problem is that the computer doesn't really know what the number of hydrogens should be. All it did was it just picked the smallest signal at some threshold value and arbitrarily set that to 1. I can see some interesting splitting in this region, so what I'm going to do is I'm going to zoom in on that region so I get a better idea about what I'm looking at. When you do that, you can see that there is some secondary splitting going on. So for instance, this one might have looked like a singlet, but in reality it's a triplet. As you're zooming, if you ever want to unzoom, all you need to do is to press minus on the keyboard. So I just minused out of that. So I happen to know that right here are two different aromatic signals. One of them looks like a doublet of doublets, and the other one looks like a doublet of triplets. We're not going to worry too much about what's going on. We're just going to try to reintegrate this. So what I've done is I've clicked on the integral line which has integrated both of these, and I'm going to press delete to get rid of that integral. So now I'm going to integrate this signal, this doublet of doublets, separately from this doublet of triplets. So to integrate, all you do is you just position the integral cursor on one side and just move it over. And you notice how it's following the contours of the plot. But here, it's starting, the new signal is starting to grow in, so it hasn't reached down to the baseline. So the easiest thing to do to get it down to the baseline is to just position the cursor over this lower right-hand square, and you'll see that there's a sort of a double-headed arrow appears. If I now click with the left mouse button and move down, now I'm at the baseline. So I'm going to do the same thing over here. And so I'm going to move across. And once again, now on the right-hand side, it's not down to the baseline, so I'm going to move it down to the baseline by clicking and holding the left mouse button again. Okay, and so what I'd like to do now is to go back to the unzoomed spectrum. So here we are. Now I know that these are not supposed to be 15.8, 16.2, 16, and 15.28. This should be a 1-to-1-to-1. So I'm going to select the smallest one here. Actually, the smallest one is over here. So I'll select this one and then come over here to Options. And I'm going to just press Enter on the keyboard. So I have normalized this integral to 1 hydrogen. If I knew, for instance, that it was more than 1 hydrogen, I could, if I thought it was 2 hydrogens, I could just put a 2 over here. So now I'm going to go back. I'm going to hit minus again on the keyboard to go back to the original spectrum. If you ever want to go quickly back to the original spectrum, you can just press home on the keyboard. So now I want to look at this signal over here, so I'm going to zoom in. And you notice that there's 2 signals here. And the computer has integrated them as one complete signal. So that's not correct. So I want to delete this integral. So I click on it, press delete. And then now I just want to integrate that signal. So I'm just going to integrate this signal. Okay? And I hit minus on the keyboard again. And so my signals are in a ratio of 1 to 1 to 1 to 1 to 3. And if you looked at the compound, you would realize that those are the correct integrations for the product. There are some other things present here. There are some impurities present, some other aromatic compounds that are present. Perhaps the starting material, starting aromatic material is still present. So I'm going to minus out of that. Now, when you present this in a lab report, for instance, it's not clear to the reader what the splitting looks like, especially in these signals over here. And that might be of interest to the reader, and or you might need to try to display this data better so that the reader can understand what you're writing about. So the easiest thing to do to display data like this is to use the function called picture-in-picture. So this is the same thing as on your TV. So here's the picture-in-picture key. And what I'm going to do is I'm going to draw a picture-in-picture right here. Now what the computer does is it automatically puts in the entire spectrum. I don't want to try to display the entire spectrum. I'm just most interested in these signals right here. So you can zoom in just there. And you can zoom in even more to make it even more clear. If you want to make the picture-in-picture larger, you can come back here to picture-in-picture. And then as I go to this square here, I get these double-headed arrows. There's my double-headed arrows. And so I can make this wider. If I press the Command key, I can move the picture-in-picture. I'm going to make it a little bit wider here. I could have drawn a picture-in-picture for just this signal and for just these 2 signals if I wanted to. The y-axis here is not necessary. So if you press Option Y on your, I'm using a Mac keyboard, you can get rid of that. And so anyway, so this is a nice way of displaying what might often be complex splitting patterns. I don't really need to redisplay this one because that's fairly clearly a triplet, and this one here is fairly clearly a singlet. Another thing that you may want to do is you may want to annotate your spectrum. One of the easier ways of annotating it is with text. So for instance, I could call this the nitration product. And unfortunately, the text is kind of small, but if you use the right mouse button, I can come and I can change the size of the text to something that's a little bit larger. So there's my nitration product. It might be easier to annotate the spectrum in a different program in terms of, for instance, putting in a structure. So that's this is a very useful way of reintegrating, zooming in on the specific area and displaying it, also annotating it. In order to save this as a PDF, you can press the printer icon and then over here, save as PDF. It'll take whatever the title was. You can change the title. I'm just going to leave this title. And when I hit save, unfortunately, it has this annoying .jdf extension. This is the proprietary software extension. So just say use PDF, and it'll automatically save it as a PDF file.